guys, welcome back to this channel. So today we're gonna talk about two big data processing frameworks, that is Hadoop and Apache Spark. Like both are powerful tools, but they have some distinct differences that make them suitable for the different use cases. So like firstly we'll talk about the processing model. As you can see here, so on the Hadoop side, like in simple terms, like Hadoop processes data in large chunks, which we call batch processing. Think of it like collecting big spreadsheets, having millions of records and processing all at once. So this can be like very slow because it takes a lot of time to handle everything together. So Hadoop was made only for batch processing. You cannot do any uh, live stream data, like you cannot process any live stream data or cannot do any real-time processing. That cannot be possible. So like here comes Spark into picture. Like Spark is very versatile in handling both batch processing and real-time processing. Imagine like Spark as a super fast data engine that stores information in memory, similar to how computer stores data in RAM. So Spark provides this in memory computation, and this makes Spark very fast. So second point is speed. So Hadoop is slower as compared to Spark because it does not support in-memory computations. So basically, in Hadoop, like the processing method is used is MapReduce, like as you can see in this diagram. So the third point is the ease of use. Okay, so when it comes to ease of use, like Hadoop is a bit like a programming in a more complex language. Like sometimes you have to work with this Java programming language that can be like very complex. But in Spark, like Spark have this friendly multi-language assistant. Like you can work in Java, Scala, Python, R languages with Spark. Like Spark provides this high-level API to support several languages. So the next point is data processing. Hadoop is very good for batch processing, which is like handling large amount of data all at once. It's not designed for real-time data processing, which is analyzing data as it comes in. Sparks excel in both batch processing and real-time data processing. Like it is best for both. So whether you need to process a large data sets or handling any live data streams, Spark can do everything. And this what makes Spark versatile too for various applications. So the next point is fault tolerance. So on the Hadoop side, think of Hadoop as a system that keeps like uh, multiple copies of your very important data across different nodes in a cluster. If one node fails, no worries, you already have a backup and you can restore the data. But in Spark uses different approach. So it uses this RDDs, what we call as resilient distributed datasets. So imagine you have a detailed recipe to cook something. So that recipe you can refer to the RDD lineage where you have all the steps, and the dish you can refer to the final output, right, or your data. So if you lose any data, you already have this RDD lineage, that is the recipe, and the Spark gonna recreate everything from scratch. So no need to worry here also. It will recompute everything if any crash happens. So Spark tracks everything, like all the transformations apply to the data. So if any data is lost, it can simply recompute it using the original data and transformation steps. So the next point is scalability. So both Spark and Hadoop are designed to handle big data, but they do it in slightly different ways. So Hadoop is very perfect for a really a large scale data storage and processing. Think of it like you have a giant traditional warehouse where you can store tons of items and process them in a batches. It's ideal for huge data sets and can scale up to the thousand of nodes. But in Spark, it is like it does the same thing, but it really shines where this real-time analytics come into picture. It likes a modern automated warehouse with robots and high-tech system that can handle large volume of data and perform quick analysis on the fly. Like you can really do the real-time analytics on the data, on the fly only using Spark. So Spark do this kind of thing in a very different way. So the next point will be the ecosystem. So like both Hadoop and Spark is very different in terms of ecosystem. Like uh, on the Hadoop side, it has its own ecosystem where it uses it uses this tools like SDFS for storage and HBase for NoSQL databases. It uses like it have this Hive and Quick for querying data and Yarn for resource management. So Hadoop have its like own ecosystem, but on the Spark side, Spark ecosystem is like very new. It uses it uses a few integrated libraries like called Spark SQL for querying, Spark streaming for real-time data processing, and also it uses this mlib there with which we can apply any machine learning models, and also it has this GraphX library for graph processing. So think of it as like a rapidly developing smart city with cutting edge technologies popping up everywhere. Okay, okay, the next point is resource management. So now let's discuss how Hadoop and Spark manage resources, right? Which is very crucial for running large data processing tasks efficiently. So Hadoop uses Yarn, which stands for yet another resource negotiator. It's like having a dedicated manager in a very big office building, right? Who makes sure that every room and resources is used efficiently. So this is what we call as a resource manager. So Yarn does this kind of activity for Hadoop. But on the Spark side, Spark is more flexible in this regard. Like Spark, Spark can decide who will be its manager, right? Hadoop have only one manager, that is Yarn, but Spark can decide you can integrate a different manager with Spark. It can run on Hadoop Yarn also, but it also have its own resource manager like Spark, and also it has this Spark can run on other resource managers also like Mesos, Kubernetes, and its own standalone cluster manager. Like as I already said, Spark. It's like having the option to choose between different office managers and even manage the office resources yourself, giving you more flexibility depending on your needs. So if I'll conclude this, both Hadoop and Spark, like both are this powerful tools for big data processing, but they cater to different needs. Like according to your needs, you can decide what you want to do, what you want to use. So on the Hadoop, if you are looking for if you are looking to process any huge amount of data in large batches, Hadoop is like the best. But if you need any if you need to process any real-time data or like very efficiently, so Spark is a better choice for that. Like it's very fast, more versatile, easy to use, making it ideal for wide range of applications, especially those requiring quick and real-time data analysis. So this is it. So next slide will be okay. Yeah. So next we're gonna talk about the differences between Spark and Pandas. So both are for data processing only, but there are some differences where we can use, like, according to those differences we can choose like what we want to use, in different scenarios. So first difference is data size handling. So in the pandas is very great for small to medium size data sets, like that can fit into your computer's memory, or you can say the RAM. So think of the pandas like you have a personal assistant who can handle a lot of work efficiently, but has a limit on how much they can manage at one time. If you try to give them too much workload, they will get overwhelmed, and then the whole processing will get slowed down. But on the Spark side, Spark on the other hand is designed to handle very very large scale datasets that exceed your computer memory. You know, it's like the same example I'll give. So you have a assistant, but you have a team of assistants. Not a single assistant. So you have a team of assistants working together seamlessly to manage a huge workload. Even if it's spread across multiple computers, this makes Spark ideal for big data applications where the data sizes is massive. So you have, as I said, on the first slide, if you have seen on the Spark overview video, there I have mentioned like how Spark manages, like it creates a partitions, you can say, of the total data sets. So suppose you have 10 million records, it won't process the whole data at once. It will process, like it will create the partitions, and it will process the whole 10 millions in a parallel processing method. So this way Spark is more efficient with the large datasets, but if the dataset is very small, then you can go for Pandas. And the performance wise, like Pandas performance operation is very very faster on the smaller datasets because it operates in memory computation, and it is very optimized for single node processing. But Spark excels in performance for the large datasets. Like if you will try to run Pandas on a large datasets, it will be like very slow, or sometime it will crash due to out of memory issue. But Spark, it also has the capability for in-memory computation, but it uses this distributed computing approach that makes is different. Like it can perform operations on large data sets efficiently by this distributing the workload across the multiple nodes in a cluster. Cluster is nothing, just a machine, a cloud machine. So the next point is ease of use. So Pandas is like on the Pandas side, like Pandas is very very user friendly and has a very very straightforward API that is easy to learn and use. It's very very like it's a great and quick data manipulation and analysis on a smaller data sets. You can think of it as a simple toolkit that's easy to pick up and start using the right way. But on the Spark side, while also providing a high level API, has steeper learning curve compared to Pandas. So it's like Spark is a powerful tool and a versatile, but it requires more setup and understanding of distributed computation. So this distributed computation concept is a slightly complex, and you have to learn a lot about the Spark, uh, and that way only you can achieve any and that way only you will achieve this efficient and more faster computation on distributed system. But on the Pandas side, it is very straightforward and very easy to learn. So on the Spark side, once you get the hang of it, like once you will learn how Spark works and how you can distribute and provide how you can distribute the data for multiple for like this distributed computation, you can leverage its full potential for large scale data processing. So the next point is APIs and functionality. So on the Pandas side, like Pandas provide this rich set of data manipulation functions. It is like you can use these functions for data cleaning, transformation, or exploration. But these functions are suitable only for single machine computation. But on the Spark side, Spark provides this similar functionalities through its Spark SQL and data frame APIs. It also includes additional libraries like Spark streaming and real-time data processing, and also this MLlib for machine learning and graphics, as I already talked earlier. So like these all these features and libraries and functionalities you can use on the multiple nodes. So these are the APIs and functionalities difference between Pandas and Spark. Next point is scalability. Pandas is very limited by this memory of single machine. Like it like we can process the small data or the medium sized data only on the single machine, so it is very limited. But on the Spark side, it is very highly scalable. You can use single machine to thousand of nodes in a cluster according to the requirement. So the next point is fault tolerance. So Pandas is very it doesn't have any built-in fault tolerance. Like if your code crashes, then it will fail, like the whole job will fail, and then you need to restart it manually. But on the Spark is designed with the fault tolerance in mind. Like it has this RDD feature, as I talked earlier, which automatically recovers from the node failure. Like as you remember that we talked about this example, this recipe and dish, right? So recipe is your RDD lineage where all the steps are defined, and using what this Spark can restore the data, by performing the each step mentioned in this RDD lineage, and it will recover everything. So it uses this RDD that helps for fault tolerance. So the next point is use cases. So Pandas is best suited for the data analysis task on the small or the medium sized data. But on the Spark, you should go for Spark only when the data set is very large, or you need to process any real-time data streams or run any MLlib algorithms on distributed data. The same thing you can do on Pandas also, like this ML model you can create, or but the difference is, if you want to perform this kind of computation on the distributed data sets, then you should go for Spark. So if I conclude, like both Pandas and Spark depends on the size of your data and the requirement. So using the Pandas is only best when the data set is small and you want to do any quick data analysis. But you should opt for Spark only when you are dealing with any large data scale data and you want to process this large scale data on the distributed computing. And you want to process this large scale data on the distributed machine, like on the multi nodes computation. Or you want to do any real-time analytics on this big data, so then you should go for Spark. So thank you for watching. If you find this video helpful, please like and subscribe and leave your comments below. So see you in the next video. Thank you.